is oxygen? Oxygen just absolutely destroyed magnesium for no particular reason. He's a big bully, hungry for valence electrons, and that's why he's epic. Valence electrons are the electrons on the outer energy level of an atom. Atoms want to have a full valence shell, meaning that there are 8 electrons in their outer shell. Unless the atoms are hydrogen and helium, which only require 2 electrons since they only have 1 energy level, that 1 energy level can only hold 2 electrons, making it a full shell. Achieving 8 electrons for a full shell is known as the octet rule. Here, we have magnesium and oxygen forming an ionic bond. This is because magnesium, the metal, is transferring its electrons to oxygen, the nonmetal. In ionic bonds, metals transfer their electrons to nonmetals. Instead of sharing electrons like covalent bonds do, ionic bonds transfer their electrons. Ionic compounds are named by putting the metal first, then putting the nonmetal, and replacing the end of the nonmetal with "ide". Magnesium and oxygen would result in magnesium oxide. To write the formula, you switch the oxidation numbers or charges of the 2 elements. Oxygen is back again, but this time he's unbonded with magnesium. He's looking for a new partner, someone that can go with his flow. Here he's met it with hydrogen. Both hydrogen and oxygen are both nonmetals, so they're gonna form a covalent bond. This time, instead of transferring electrons, in a covalent bond they share their electrons. Hydrogen and oxygen hold hands to share an electron. This is enough for hydrogen, but it does not satisfy oxygen enough. Hydrogen has 2 electrons now, which is enough for her, but oxygen only has 7 and needs 8 to have a full outer shell. What oxygen does is be a bum and pull in another hydrogen. The first hydrogen is shocked, but oxygen does not care. He wants to be satisfied. Proceeding to hold hands with the second hydrogen, oxygen and the hydrogen share electrons, and now oxygen has a full valence shell. Well, they sure do flow well together. The way to name covalent bonds is to first write the name of the element which appears on the periodic table to the left first, then write the name of the next element, changing the ending to "ide", then adding the prefixes to the beginning of the words. The only exception is to not put mono in the first word. The prefixes are according to how many of the element there are: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Writing the compound formula is also the same process as for ionic bonds. Periodic trends affect bonding depending on what location the element is placed on the periodic table. As you go from left to right, the reactivity of the elements decrease, making it harder for atoms to transfer or share electrons to make an ionic bond or covalent bond. This is due to the amount of valence electrons the elements currently have. Any element to the left of the metalloid line are metals, while any element to the right of the metalloid line are nonmetals. This determines whether or not atoms will form ionic bonds or covalent bonds.